पकड़ लेता
जो खोल लेगी और अपन खोल दे दो। Hello, am I audible now?
Yes, ma'am.
Yes, ma'am, you're right.
Okay. So let's start. So today we will study Euler's formula and how we can compute the root, nth root of unity. So nth means so if we take what is the square root of unity. So if we consider the polynomial, which is x square minus 1 is equals to 0, then we can find out the root of the this polynomial just by factoring it, right? So it will be x plus 1 and x minus 1 is equals to 0. So here x is equals to plus minus of 1. So that means what we can say, the cube root of 1, because this is what? So this is all x whose square is equals to 1. So you can say that the cube root of 1 are nothing but 1 and minus 1. Because if we square these two terms, then we will get 1. 1 square is also equal to 1 and minus 1 square is also equal to 1. Now what about the cube root of unity? So that means we have to find the solution of the polynomial x cube minus 1 is equals to 0. So ultimately we want to find all those x whose cube is equals to 1. So what will be the answer here? Or in general, if we take any natural number, so for any n belongs to natural number, what will be the what are those values of x for which x to the power n is equals to 1? So this is our goal, and this is these all x we want to find out. So how we can do that? So for that we use Euler's formula. So before Euler's formula, we try to explain what is the exponential e to the power I theta is. Okay, so we know that e to the power x is a function which we define via the power series. So for us, e to the power x is nothing but a power series defined by 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. So this is the general power series associated with the function e to the power x. We know that e to the power x can be expressed by this power series for any real number, or any x belongs to real number. And why is this the case? We already know that if you consider this as our power series, then the radius of convergence of this power series is nothing but the whole real number. So that's why we can define a function using power series whose domain is nothing but the whole real number. Now our aim is to define e to the power. Yes.
Ma'am, can I ask two questions? Can
Yes.
you tell any real life example of a complex number, and why we learn after the complex number trigonometric function? Any relationship between complex number and trigonometric function?
Yeah, so the relation is this unit circle. So for example, if we draw a unit circle, so then over the unit circle, we have two descriptions that any point of the unit circle can be given by cos theta and sin theta. Because we can simply draw a triangle here, a right angle triangle. And if this is the angle theta, then we know that this particular length will be our sin theta. right? And because this length is 1, we are considering the unit circle, so that's why the radius is 1. So this particular length is sine theta, so that's why the coordinate of this point, the y coordinate will become sine theta, because this length is same as the covered over the y-axis length. And similarly, this length is same as uh, cos theta, right? Because we know that what is our cos theta. So cos theta is particularly this length upon hypotenuse. So if I consider this point to be equal to m and this point equal to O, so then cos theta is nothing but OM upon 1. So that's why the coordinate of this point is cos theta comma sin theta. But this is the condition when we consider that this is our general plane, right? General xy plane. General xy plane, or general plane if you consider, then these are the coordinates. But if you consider this plane to be your complex plane, right? So if we consider this to be your complex plane, so what is our complex plane? Complex plane means here this will be your real axis, this will be your imaginary axis, and any point can be given as a plus iota b, right? Where a is this particular distance and b is this particular. So ultimately we have the same plane, but the description changes into complex numbers. Okay. So that means we can actually define this particular, or the location of this particular point, using the complex number 2. And what is that complex number? That is our main aim to find out. So here the e to the power I theta comes into picture. So if you consider this particular point over the unit circle, then the coordinate of this point will become e to the power I theta. Okay.
Okay, ma'am.
So right. So that's how we can relate our real life trigonometric function using complex with the complex number. And we have so many formulas for complex numbers, so we can have certain trigonometrical properties using with the help of complex number too.
Because
Okay.
in previous classes, we don't teach trigonometric function, and suddenly after complex number,
Yeah.
uh,
Hmm.
so
So
on.
see, there are so yeah. Let's go on.
Yes, yes, ma'am. Tell me.
Yeah, so see, for defining trigonometric function, there are so many different ways. So we can define that trigonometric function is nothing but the coordinate of point lying over a unit circle. This is another one way. Okay, and
Okay.
also we define trigonometric function using power series tool, right?
Yeah, yeah.
So we use
And
that description.
do you know any real life example of complex number? But I
Real life example for complex number. Okay, so uh, you want an example except mathematics, right? I mean, not this particular side course. So see, there is if you go in little bit of higher
yeah,
complex number, complex theory.
it's like any general example of a complex number. They can use day-to-day life, like as programming and other concepts like that.
Okay, okay. So about programming, actually, I don't know, but in calculus, I can tell you one example.
Okay,
So
ma'am.
in calculus, if you know, we are computing RK, right? So there are functions. Suppose uh, what can we say? Suppose I have a curve which goes like this. Okay. So suppose such a type of curve is here and it closes at some point here.
Okay,
Then using complex number theory, we can actually say that the arc length of such kind of curve is nothing but 0. So this is one of the theory in complex analysis, which is known to be the Cauchy's formula. So Cauchy actually, what does he? I mean, what's his work is? So his work is to find out the arc length of a very general curve. So, for example, if you have such kind of figure which made by the curves, suppose you have such kind of figure. So this is more abbreviated. So take some intersection points and all those things. Suppose you have such kind of curves, right? This is your
yeah,
curve. Now, what does Cauchy did? So Cauchy find out the integration of some function here, which is related to this particular curve. And for that finding, they uses complex numbers. So it is a little bit higher of complex analysis, but yeah, complex analysis used in this way also. It is also
Okay, okay,
related to some curve and then finding out the arc length of the curve and so many things.
okay, ma'am. Thank,
Okay.
okay, okay. Thank you.
But yeah, basic complex theory we need it for finding out the so main purpose is finding out the nth root of unities. So this is our main
Okay,
purpose
okay,
to
ma'am.
find out.
Okay,
Okay. So let's start. So now we want to define what is e to the power iota theta. So what it will be. So we know that e to the power x can be defined by series. So we'll try the same thing with e to the power iota theta too. So e to the power iota theta, then it will be equal to that 1 plus iota theta plus iota theta the whole square by 2 factorial plus iota theta the whole cube by 3 factorial plus iota theta to the power 4 by 4 factorial plus and so on. But we know what is our iota. Iota is nothing but under the root of minus 1. What is iota square? So iota square is minus 1. What is iota cube? Iota cube is minus 1 into under the root of minus 1, which is minus of iota. And iota to the power 4 is same as iota square into iota square, which is equal to minus 1 into minus 1, which is equal to 1. And we will get the same value of iota to the power 5 is same as iota to the power 4 into iota. So that's why it's equal to iota. So here we have change. Change means first value will be iota, then minus 1, and then minus iota, and then plus 1. Again iota, again minus iota, again minus 1, then minus iota, and then plus 1. So iota to the power, if you want to find out some power of iota, we will get only one of these four numbers. Either we will get 1, or we will get either we will get 1, or we will get minus 1, or we will get iota, or we will get minus iota. Okay. So now we will replace all these power of iota with the suitable quantity here. So if we do that, what will be the result? So the result will be 1 plus iota theta. Plus we know that iota square is nothing but minus 1. So this will change into minus of theta by 2 factorial. And iota cube is nothing but minus of iota. So it will become minus of iota of theta cube by 3 factorial. And iota to the power 4 is 1. So this will be theta to the power 4 of 4 factorial. And if we do in the same way, we'll repeat this particular pattern. So that means first we'll have iota theta to the power 5 by 5 factorial, then minus of theta to the power 6 by 6 factorial, and plus of iota theta to the power 7 by 7 factorial, and then plus theta to the power 8 by 8 factorial, and then again repeat the same thing. So now here we observe that if we connect all the terms with the iota, then we will get some nice series. Okay, so what will be that series? Let's write it down. So if we collect all the terms with the iota coefficient, so then here we will get 1 minus theta by 2 factorial plus theta by 4 factorial minus theta by 6 factorial, theta to the power 6 by 6 factorial plus and so on. And I'll take iota common plus of iota. And then here we have theta minus of theta cube by 3 factorial plus theta to the power 5 by 5 factorial minus theta to the power here there should be minus theta to the power 7 by 7 factorial plus and so on. So we know that this series is nothing but cos theta and this series is nothing but sin theta. So ultimately what we get, so we get that this one implies e to the power iota theta is nothing but cos theta plus iota sin theta. Okay. So now using this form, we can actually prove so many trigonometric equalities. So let's try to prove some of them. So one trigonometric equalities we can prove that cos of 2 theta is nothing but either cos square theta. Okay, so we have all those trigonometrics, but let's go to the Euler's formula. So what is the Euler formula? And then we go other trigonometry. So Euler's formula is
Ma'am,
So what? Yes.
can you tell me what is the actually cos and sine? I'm right now studying engineering, but I don't know what is the cos and sine. It is a particular value or particular sign. Yeah, it's a represent only wave. I don't know.
See, okay, I'll tell you that. So basically, cos theta and sin theta is nothing but the ratio. So if you consider any triangle, any right angle triangle, so suppose this is your right angle triangle. So any right angle triangle, no matter what is the size, so you can consider the small one, you can consider the large one, or any triangle. Until and unless this side, this angle theta is same, if you compute the ratio of this side and this side, and this side and this side, that ratio will be same always. Okay, and that ratio is known to be cos theta. So cos theta is, suppose I'll take it to be O and M. So it's nothing but OM by ON. No matter how large, how small you will take the right angle triangle, until and unless this
It
angle theta
will
is same,
give the same value.
it will give you same value.
Okay,
If
okay,
you want, you can try with 2 to 3 triangles, make them various size, and then compute
okay,
the ratio. Okay, so
okay,
it will, that's the thing. It will always be a same value. That's why this sine and cos function is important to us. And also, if you compute the ratio of, if you compute the ratio here with this side and the hypotenuse, that will be your sine theta. That's why they this ratio named to be a very specific function cos theta and sine theta, because they won't vary until and unless the angle is same. The angle theta is same. Okay.
okay, ma'am.
So sine theta is nothing but mn upon on. Now we can relate this description with the circle too, because we can draw a triangle inside a
Yeah, yeah.
unit circle too.
It's I
Right?
know. In my 12th and 10th class, no teacher explained like that. They
Okay.
only
Yeah.
say is the hypotenuse upon sorry, opposite side upon a hypotenuse is sine theta. Was
Mhm.
only that.
Yeah. So there is another reason why these ratio will be same for our triangle, because see here the theta is same for these two triangles, and the angle 90 degree is also same. So whatever angle here will we will get, that also same. So ultimately they will become the similar triangle. So we know that if some triangle in some triangle, if three angles are same, then the ratio of sides will be same. So from there we get that these two ratio won't change if you change the side of a triangle too. So that's why such kind of
Okay,
ratio
ma'am.
is known to be sine and cos. Okay.
Okay, okay. Thank you, ma'am.
So now let's go to Euler's formula. So Euler give us a very good formula which we can use to find out cos theta plus iota sine theta to the power n for any n, for any n belongs to the set of integers. Okay, so how we do that? So we know that cos theta plus iota sine theta is nothing but e to the power I. So this is same as e to the power I theta to the power n. But we know that the power rule says that this is same as e to the power n theta iota. Right? So here we can replace theta by n theta, because here this is what? This is e to the power some angle into iota. So this is same as cos of n theta plus iota sine of n theta. So this seems like a very simple formula, but it is a very tremendous use, which is that we can find out the root of or nth root of any number. No matter whatever the number we have, we can find out the nth root of that number. So the formula will become here that cos theta plus iota sine theta to the power n is actually equal to cos n theta plus iota sine n theta. Okay, this is also known as De Morgan's formula, if you guys remember that. Okay, now let's go to how to find the root of unity, nth root of unity. So if you consider the circle, if you consider the unit circle, suppose this is a circle, so then it will meet at this point. And we know that this point is nothing but 1. So that means the length from 0 to here is 1, because we are considering this to be a unit circle. So this is 1. And what is the angle here? So angle here is 0 degree. So we know that this can be written as, so that means here it is 1, and 1 is same as e to the power 0, correct? And this is same as e to the power uh, 2 pi iota, right? Because what will be e to the power 2 pi iota? E to the power 2 pi iota will be cos 2 pi plus iota sine 2 pi. and sine 2 pi is 0 and cos 2 pi is 1. So that's why it's same as e to the power 2 pi. This is same as e to the power 2 times 2 pi r. Because again we will get 4 pi and we know that cos and sine will have the same values at any multiple of 2 pi. This is same as e to the power 4 of 2 pi iota, right? And so on, e to the power 5 of 2 pi iota, and so on.
Sorry
We
for the
can do
interruption,
is,
ma'am.
yeah.
Ma'am, is if possible, could you please slow your pace, ma'am? It's very hard for me grasping in too fast.
Okay, okay, yeah,
Yes,
sure, sure,
ma'am.
sure.
I'm
Fine.
also.
Okay. So,
Ma'am,
yeah,
if possible, please re-explain the previous slide also.
this one.
Yes, ma'am.
So here our aim is to simplify this step, that cos theta plus iota sine theta to the power. We want to simplify this. So, but we know that this cos theta plus iota sine theta, this is same as e to the power I theta, right? We just proved, because if we do the series expansion for e to the power I theta, it will give us this particular form, right? It's same as e to the power I theta is cos theta plus iota sine theta, right? So we can replace this quantity by e to the power I theta, but we also have power n. So we know that by power rule that if we have a to the power r to the power s, this is same as e to the power r into s. This is the general power rule for any number. So here you can consider that A is your E, R is your I theta, and S is your N. So by this particular power rule, we can say that, or power formula, we can say that this term is nothing but e to the power n theta I, or you can say that this is same as e to the power ni theta, but it's same as n theta I. So what we can do, so we know that e to the power I theta, so e to the power iota theta is actually equal to cos theta plus iota sine theta. So what is theta here? Theta is the angle we are using with iota. So here what is our angle? So here angle is not theta now. It will become n theta. So that's why in place of theta we can replace n theta and we can get this form. Is this clear now? This is also n.
Yes,
Sine
ma'am.
n.
Now it's clear, ma'am.
Now our goal is to find out roots of unity. So what is root of unity? So that means we want to find out all the value of x, for which if we compute x to the power n, then that should be equal to 1. This is our goal. So we want to find all those x, for which x to the power n is equals to 1. So what we are doing, first we are observing that how we can write 1 in terms of e to the power I theta. Okay, so if we have the unit circle, so then we know that over the unit circle we can write points using e to the power I theta 2. So because if we have a complex plane, then then the coordinate of any point, so any point can be written as a plus iota b, right? And if we have a unit circle here, so suppose this is unit circle, so then we know that this point is same as cos theta plus iota sine theta. Because again we know that that any point of the unit circle we can describe it as cos theta comma sine theta, but if we are in a complex plane we can also write it sine cos theta plus iota sine theta. Okay, is that clear? This is a unit circle.
Yes, ma'am.
So that means for any point which is lying over unit circle, we can describe it using the e to the power I theta 2. And what is the theta here? So theta is the angle made by the line with the x-axis. This is your theta. So that means any point over the unit circle, we can describe it using e to the power iota theta 2. Okay, so this is the main point. Also, we know the polar coordinate of any point, right? That is r e to the power I theta. So, but we won't go there. So now, how we can write this particular one, because we know that this distance is nothing but 1. So now we want to find out several ways to writing 1, because ultimately our aim is to find all x for which x to the power n is equals to 1. Okay. So now we try to find out how we can write this particular value 1 in different ways using e to the power I theta. So what will be the angles there? So initially here, if you consider this particular line, the red line, then this line making the angle 0 degree with x-axis, right? So initially the angle is 0. So that means this 1 can be written as e to the power 0, right? Into iota also we can take e to the power 0 iota. But we know that that cos 2 pi is same as cos 0. Cos 0 is same as cos 2 pi is same as cos 4 pi, right? Cos 0 is same as cos 2 pi, same as cos of 2 into 2 pi, right? That is nothing but 4 pi. And this is same as cos of 3 into 2 pi. And so on. Because we know that the cos function will take same value as we repeat over 2 pi distance. Right? I hope this fact is clear to you. And similarly, sine 0 is same as sine 2 pi. This is same as sine of 2 times 2 pi. Right? And this is also same as sine of 3 times 2 pi, and so on. Because again, the period of sine function is also 2 pi. So cos and sine function will take the same value if we multiply the same value over the distance of 2 pi. If you consider the distance here, then the distance between 0 and 2 pi is 2 pi, right? From 2 pi to 4 pi, we are covering 2 pi distance again. From 4 pi to 6 pi, 6 pi is same as 2 multiplied by 2 pi. Again, we are covering 2 pi distance. So that's why all these values are same. So that means we can say that e to the power 0 iota, which is same as cos 2 pi, which is same as cos 0 plus iota sine 0, same as cos 0 plus iota sine 0. We can write it also by cos of 2 pi plus iota of sine 2 pi. Right? But what will be the value of this in terms of e to the power iota theta? What you can write this? You can write this e to the power 2 pi of iota. Correct? Is that clear so far?
Yes, ma'am.
Right. Now similarly, we can write cos 2 pi as cos 2 multiplied by 2 pi, which is nothing but cos 4 pi plus iota times sine of 2 multiplied by 2 pi. Right? And this is same as e to the power 2 multiplied by 2 pi of iota. I'll let you know why I'm not writing this as 4 pi and writing 2 into 2 pi, because we find out a pattern here. So here initially this was 1, and here also it was 0. 0 multiplied by 2 pi also you can think about it. So that means we are following some numbering here. So let's write one more term. So this is same as cos of 3 multiplied by 2 pi plus iota sine of 3 multiplied by 2 pi, and this is same as e to the power 3 multiplied by 2 pi iota, and so on. So ultimately what we get, so we get that 1 we can write as 1 is equals to 1. 1 is also equal to e to the power 2 pi. Iota is also equal to 1. E to the power 2 times 2 pi iota. This is also equal to 1. Right? And e to the power 3 times 2 pi iota. This is also equal to 1. And so on, e to the power n times. Suppose I'll take any natural number n. N times 2 pi iota. This is also equal to 1. Okay. Now what is our aim? So our aim is to find out all those x whose x to the power if I'll do, I'll get 1. Okay. So now here, if you observe here, if we observe that if we take the nth root here, what is the nth root means?
Ma'am,
Yes.
you mean say I take a value of pi as 2 pi, multiply by with I and raised to the power e, it's give me 1.
Yeah, e to the power 2 pi iota, this will give you 1. Because what is this? This is same as cos 2 pi plus iota sine 2 pi. And sine 2 pi is nothing but 0 and cos 2 pi is nothing but 1. So that's why it's
If I,
equal to 1.
if I do this operation in calculator, it's matlab,
It will give you 1. You can do it. But
okay,
in calculator, I don't think it will support iota. So,
yeah,
so if scientific calculators, if your scientific calculators support iota, then it always also, obviously give you 1.
okay, ma'am.
Okay. Now our aim is to
Because
find out all those. Yeah.
in lectures professor say sine 0
Mhm.
divided by 0, it will give a 1, but when I take in the calculator, that give me error.
Yeah, because sine 0 is also 0. Oh, it is giving you error. So sine 0 divided by 0 you are doing, right?
Yeah,
Sine 0 divided by 0. So yeah, so here the issue is calculator don't understand dividing by 0.
Okay.
He
Yeah,
assumed that if you divide any number by 0, it will be undefined.
yeah, it will be in
Okay.
indeterminate form. So that's why it's given in.
Indeterminate form.
Okay. Okay, ma'am.
Whereas sine 0 by 0 is not 1. If you compute the limit, then that limit is equal to 1. Limit x going to 0,
Yes.
sine,
Actual
sine x
question
by
is
x.
this is yes.
This
Actual
limit,
question is
this is actually undefined.
yeah.
So this limit is 1. You can prove it by L'Hospital too, because we will
Yeah.
get
I know
0
it.
by 0 form.
Yeah.
So now here our let's get back to here. So here our aim is to find all those x whose nth root is equal to 1. So now here we are getting some feeling that okay, these all numbers are equal to 1. And why I stop at n, that will also I'll tell in a moment. So here what you will do, you'll just take you in the power e to the power. So here we have e to the power 2 pi. So here we have e to the power 2 pi iota. So we can write it as e to the power 2 pi iota multiply and divide by n. Correct? This won't affect our quantity because we are multiplying and dividing by. So this is same as e to the power n 2 n pi iota upon n. Correct? I'm just adjusting n in the numerator and denominator.
Yes, ma'am.
But we know that this is same as e to the power 2 n pi iota multiplied by 1 by n. But any numbers power 1 by something, we can take it as nth root of e to the power 2 n pi iota. Okay, so that means we can replace this one as, so this one as nth root of 1, because we know that if we take any power of 1, it will become 1 only. This is same as nth root of e to the power 2 n pi iota. Okay, and this is same as nth root of e to the power 2 multiplied by 2 n pi iota, right? And so on. Ultimately, nth root of e to the power n times. Did I make any mistake here? Oh, I have to go up to n minus 1 only because this will give us the same value. So here n minus 1, because we started with 0, so that's the reason. So it is e to the power n minus 1 times 2 n pi iota. Am I doing
Ma'am, 2 n pi I
2? So
is wrong.
yeah. So here this is wrong. Only 2 pi iota I'll take.
Yes, ma'am.
So this is 2 times 2 pi iota, and this is same as e to the power n minus 1 times 2 pi iota. So ultimately what we are getting that if we take this quantity e to the power 2 pi iota multiplied by some k upon n, where this k is between 0, 1 to n minus 1. Now, if you calculate the nth root of this, if you calculate the nth power of this particular quantity, so suppose this is some other complex number z, and if I calculate, or you can take x since we have started with x. So suppose this is your x. If you take this to be your x and you will calculate x to the power n, then this is same as e to
Ma'am,
the power 2 pi iota. Okay, yeah.
ma'am, but you write this is expression k,
Mm.
but k when this expression is correct, k equal to n because you write
It
like
will
that
repeat. It
and
will repeat the
and
quantity. That's why.
you like a write like as n by n when you
Huh,
did not change any expression when
what is
now you write as a k
mm,
and when I take a k1 and n2
mm.
then it's not like that 2 by 2 is not affect an any expression my after expression
So you want to take k from 1 to n,
No, ma'am.
right?
His doubt is that he is basically thinking that k and n are both his variable, but he didn't get the n
Oh,
is a fix. Only k
no,
is a
no, here
variable.
n is the fix. Yeah, so here n is fixed number. So we'll fix n first. So we'll fix n first. Because our question is find the cube root of unity. If the question is cube root of unity, then we'll take n to be equal to 3. Find the nth root of unity means n is fixed first. Okay, so we'll fix n first and then we vary k from 0 to n minus 1. So if you vary k from 0 to n minus 1, if you'll it will give you n distinct roots, n distinct number.
Okay, okay, ma'am. Yeah.
Yeah, because if you take k is equals to n also, then that will be same as taking k is equals to 0 and so on. Okay.
Okay,
So
okay.
here if you compute x to the power n, then this is same as e to the power 2 pi I k, and we know that this value is nothing but 1. So these are all x which we need. So now what are the, so if someone asks what is the cube root of unity, cube roots of unity. So cube roots of unity means all those x for which x cube is equals to 1 is true. Okay, so then they, so we have exactly 3 distinct number, and what are those numbers? So first is 1. The second is, because here we have to take k from 0, 1 and 2, right? Because here n is 3, so n minus 1 will become 2. So if you take k is equals to 0, e to the power is 0, right? So our answer is in this way. So we have to take k from 0, 1 to 2, and the value of x is e to the power 2 pi I k by n. Okay, so here n is our 3 now, correct? Because this is our n.
Okay, ma'am.
So n is 3 now. So the first number, if you take k is equals to 0, e to the power 0 will become 1. The second number will become e to the power 2 pi I into 2 by 3, which is same as e to the power 4 pi I by 3. Right? So this will be your second root, and the third root will be e to the power 2 pi iota into 2 by 3. Right, I'm making stuff here. Here first we'll take 1. Because k is equals to 0 I took, k is equals to 1 I took, and now k is equals to 2. So this is same as e to the power 4 pi iota by 3. So these are the 3 cube root of unity. 1, e to the power 2 pi iota by 3, comma e to the power 4 pi iota by 3. Okay. So in this way, we can actually find out what is the exact nth root of unity. Is that clear?
Okay, ma'am. Ma'am, can you scroll up
Hmm.
again, ma'am? Ma'am, can you explain again
Yeah,
this
okay. So
whole thing?
actually I made mistake there, so that's why it came up with it. So ultimately we know that 1 is equals to 1. So if you take nth root here, so nth root of 1 is also equal to 1. Okay. Now we know
Yes.
that this 1 also can be written as, so this is one step, this is all clear. Now this 1 also can be written as e to the power I 2 pi, right? And this is
Yes,
same
ma'am.
as if you take nth root here, so we can take the nth root of e to the power 2 pi iota. Then that's also equal to 1. So that means nth root of 1 is equals to 1. Nth root of this quantity is equal to 1. So that means e to the power iota 2 pi by n, if you take, then this quantity's nth root is also equal to 1. That's the meaning here. Okay, so let's go with so as we did
Can you
one,
again
yeah,
can you
yeah,
again
I'll
explain this? It's
so
very
see, we know
confusing.
that, right. Nth root of 1 is 1. So
Yeah,
1 we can
yeah,
write out e to the power 2 pi iota, e to the power 2 into 2 pi iota, and so on. Right? So I'll take this quantity. So as we did here, the same thing we know that nth root of, in place of 1, in place of this one, I'm replacing e to the power 2 pi iota. And this is equal to 1.
yeah,
Is that clear now?
yeah.
So that means uh, uh, with saying that this is nth root of 1 and this is same as 1. So ultimately we are getting 1 here. So if you consider the value x to be equal to this particular quantity which is e to the power 2 pi iota, nth root of 2 pi iota, which is same as e to the power 2 pi iota by n. And if you take x to the power n, then that x to the power n is e to the power 2 pi iota by n to the power n, which is equal to e to the power 2 pi iota, and that is equal to 1. So this guy
Okay, okay,
is a 1x for us, one number for us.
okay, okay.
Okay,
Thanks,
fine.
ma'am.
And similarly, we can take another one. So this will be your x1. If you take x2 to be the nth root of e to the power 2 into 2 pi iota, then this will be same as e to the power 2 into 2 pi iota by n. Right? And if you take x2 to the power n, then that's also equal to 1. So this will be our second K root. So here you observe we are just taking the particular value of k. Initially, 1 is nothing but k when equal to
Ma'am,
0.
I thought n when you change the second term, I thought n is changes,
Okay.
but you can take a 2 into 2 pi iota.
Right. 2 into 2
Okay,
pi. So n is fixed. We are just changing k here.
okay, ma'am.
Yeah, initially I explained by n, so I think that's why it's a little confusing.
Yes, ma'am. If
Yeah.
you can change the n, it will, I think, also give same value.
If we change the n to
And to any number, I think it gives same value because
uh
2 pi iota e raised to the 2 pi iota give 1 and 1 raised 1 under root of nth root is 1
yeah,
and
we'll get one, but see, we want nth root of, I mean, first we'll fix one quantity for root, that how many roots we want, and then changes the value of k. So
yeah,
that's
yeah,
the reason. Because if you look at the what are the, I mean, uh, the two root of unities, right? The two root of unities. What you're saying was correct. Because if you look at two root of unity is nothing but 1 and minus 1. Because if you do the square of these two quantities, you will get 1. And the four roots of unity. So the fourth root of unity is 1 minus 1 iota and minus iota. So here we are getting two same values, whereas our n is 4, right? Two same values we are getting. If you take n is equals to 2, then also you will get these two quantities to be same. If you take n is equals to 4, then also you will get these two quantities same. So yeah, there will be some values of n for which we'll get same roots, but it also depend on how many roots you are talking about. You are talking about the cube root or two root of unities or four root of unities and so on.
yeah.
Fine. So that's all we have. So let's start with doubts from activity and practices. So if you guys have any doubt in activity and practice, we can
Ma'am,
solve that. So
can you solve some questions they can professor provide in lectures?
okay, so which question?
I think last one lecture they will be give me questions like limits with sin theta cos theta, integration with sin theta cos theta, derivative with sin theta cos theta.
Okay, so I'll share. Yeah, I'll just see the question.
Can you open the week 10 last one lecture
Yeah.
and last of the lectures? I think they will show.
Mm. So these are the slides. Which question?
Yes, ma'am. Can you scroll down all out
At the end.
at the end? At the end, not. I think
This is the problems here.
no,
Mm. This one.
no. After that,
Yeah, the PDF ends here, so I think it will be.
Okay, okay, okay. Ma'am, before this. Yeah, yeah, yeah. Ma'am, wait, wait, wait.
Hmm.
Scroll up. Yeah, yeah. Yeah, this one.
These e to the power, simplify the following.
Yeah.
Okay. Okay, Shivkumar, I'll replace the YouTube link.
Thank you, ma'am.
So these are the your questions, right? So the first one is kind
Yes,
of
ma'am.
easy, right? So in the
Yeah.
first one, it is e to the power iota pi by 4 plus e to the power minus iota pi by 4. So what we can do, this is same as e to the power I theta. For e to the power I theta, we have formula cos theta plus iota sin theta. So if we apply the formula, it will become cos of pi by 4 plus iota sin of pi by 4, and then plus of cos of minus pi by 4 and plus iota sine of minus pi by 4. But this sine of minus pi by 4 is same as minus of iota sine of pi by 4. So this will get cancelled out. So we'll, and cos of minus pi by 4 is same as cos of pi by 4. The
And
basic
ma'am,
sine and cos. So
sir
which question are
told
you facing?
me next lecture we will solve the e to the power I into pi equal to minus 1.
Yeah, e to the power iota into pi is minus 1. That's correct. So how we can show that? So here, this is also the same. Just apply the formula. This is same as cos pi plus iota sin pi. The value of sin pi is 0 and value of cos pi is minus 1. So that's why it's equal to minus 1. So
Okay,
everywhere you
okay.
can use the formula. You just have to replace
Yeah,
sin and cos and you will get the simplified version.
yeah. Okay, ma'am.
Okay. So you can solve every question, right? Just replace e to the power I theta by cos theta sin theta. All the thetas are
Yeah.
here finite quantities. So we
Ma'am,
can
I
do.
have a more question. Can I share my screen?
Yeah, you can share your screen. I think you can share your screen, right? You have access. And if you guys have any doubt in any activity or practice, just mention in the chat box as I'll also solve it. Okay. Okay, these questions evaluate the following limit. So limit x going to pi sine of. Okay, so which question you want to solve? Wait, I'll take the screenshot and then
Yes, ma'am.
yeah, I have taken the screenshot. Now you can stop stream and let me know which question you want to.
Okay, ma'am.
Okay, so which one?
Ma'am, integration, first and second.
Okay, first and second integration. Mhm. So first integration, I think it will just use the substitution or something. So let's try. So here integration is 0 to pi by 6 of 1 minus cos 3t into sine 3t dt. Okay. So this is a question before complex number, right? Or after complex number?
After complex number.
Okay, so do we have to
Because
use...
before complex number, we don't have a sine and cos type of function.
Okay, right. So it's not that difficult. I think we just distribute sine 3t here. So let's take sine 3t dt and then minus of integration 0 to pi by 6 cos 3t sine 3t dt. And now replace, now this integration we know how to solve, right? Just we need to
Yes.
solve this one. So for this one, you can use substitution. So let's take x is equals to sine 3t. Okay. So then dx is equals to the derivative of sine 3t will become 3 times cos 3t dt. So you can replace cos 3t dt with 1 by 1 by 3 of dx. So this one implies cos 3t dt is same as dx by 3. Correct so far?
Yeah.
And the integration of this will become minus of cos 3t by 3, 0 to pi by 6. Just the basic formula, right? Integration of sine ax, sine
Yeah.
cos ax. And this will become minus of integration. Now you have to change the limit too. So if t is equals to 0, x will be equal to sine of 0, that will equal to 0. And t is equals to pi by 6. So if t is equals to pi by 6, x is equals to sine of 3 into pi by 6. This is same as pi by 2. Because, right, so this is same as 1. So the limit will change from 0 to 1. And cos 3t dt will change to dx by 3. And in place of sine 3t, we just have x. Correct?
Yeah.
So now this is same as minus 1 by 3. I'll take common and apply the limit here. So it will become cos of pi by 2 minus of sine of, minus of cos of 0. And then minus of 1 by 3 also I'll take common here. X square by 2 will become, okay, so x square by 2 we have 0 to. So again we know that cos of pi by 2 is 0, cos of 1 is 1. So here we'll get minus 1 by 3, 0 minus 1, so that means minus 1. And again minus 1 by 3, and here 1 by 2 minus 0. So this will become 1 by 3 and minus 1 by 6. So the answer will become 1 by 6. You will just take LCM, 6 minus 3. So, sorry, 1 by 2. So here 3 by 6, which is equal to 1 by 2.
Yeah.
Okay. So that's how you can solve. The second one too, no? The second one
Yeah,
says
ma'am.
integration 0 to 2 pi cos x upon under the root of. So here also you just have to use substitution.
Okay, ma'am.
So if you guys have any doubt in activity, practice, assignment, find it out and mention in the chat box. I'll go one by one. Okay, so here I is integration 0 to 2 pi cos x dx upon under the root of 4 plus 3 sin x. So here also, see, whenever you have combination of sine and cos, just observe which function is there with dx. So here with dx, cos x is there. So we have to take substitution. T is equals to sine x. But here, if you take t is equals to sine x, then okay, so if you take t is equals to sine x, then if x is equals to 0, e is also equal to sine 0. Sine 0 is same as 0. And if x is equals to 2 pi, then also t is 0, sine 2 pi, which is again 0. So ultimately, if we take this substitution, we will get integration from 0 to 0. And this dt will become cos x dx. So this cos x dx will change to dt, and upon integration of 4 plus 3t. So as the answer is 0, because if we made this substitution, we are getting answer to be equal to 0.
I don't know this answer. What is the answer? And professor does
Uh,
not told.
right. So what we can do? Okay, so in this substitution we are getting the same limit. So what we'll do is split our limits and then that try to compute. So that means we can change this I from 0 to, if we take 0 to pi also, since I want to make t is equals to sine x. So sine 0 is same as sine pi, is same as sine 3 pi by 2,
Two.
right? All those
Yeah,
things are
yeah.
equal to 0. So that's why we have to change it from 0 to pi by 2, and then pi by 2 up to 2 pi we have to make as such. I think that will be our calculation here. Okay. So just try it in this way, that try to split your limit in such a way that you won't get the same limit, and then try to compute what will be the value of integral. Okay. So I think it will take a little time. Is that fine for you, Susan?
Yes, ma'am.
Any other doubt? So see, in the first limit, first you have to use the continuity of sign.
Yeah.
So what? Right. So you can take this limit into inside, and then you can compute
And second, L Hospital rule.
it. L rule. Third also L'Hopital rule.
Hmm.
And fourth one, two, I guess. No, fourth one. Yeah, in the fourth one you have to factor it out under the root of 9,
Yeah.
and then use the second limit. So
And fourth one, if I use L Hospital rules, then I think not
L'Hopital
possible.
rule, it won't. Yeah, it is possible because 0 by 0 case you are getting. So
Yes,
that's
yes,
also
yes,
okay.
ma'am. Yeah.
Yeah, using the substitution we are getting same upper and lower limit. So answer will be 0. So answer should be
And
0, I guess, because we are this function is not discontinuous at any point. Because if you observe this function cos x upon under the root of 4 plus 3 sin x, then it's kind of a rational function, right? And from 0 to 2 pi, the value of sin x, yeah, we have to take care of root 2. So if root is becoming negative, then it won't define. But I think from 0 to 2 pi, also whatever negative value it will take, it will always less than 1. So I'm convincing you that this particular integral is actually equal to 0, that we can use this substitution t is equals to sin x. We can
ma'am,
use, and the answer should be 0. Yeah. Yes,
can
sir.
you take some example of substitution of integration? Because I'm not well in integration.
Okay,
I
so
I saw the your lecture two times, but I'm not well. Can you take
okay,
some
so
example?
yeah, it actually also depend on practice too. But currently, let me find out some example. I'll go to the session. So if you guys have any doubt in activity practice, you can mention, or else we can just solve some of the question. So I'll just find out some
Sorry
example.
for interrupting you, Sujal, but my phone battery is getting down. That's why I am asking in middle. Ma'am, could
Okay,
you
okay.
please open the activity to 10.2?
Yeah, yeah, sure. So first I'll go to activities because
Yeah, yeah, yeah.
activity 10.2, no?
Yes, ma'am.
Which question?
Ma'am, last one.
Consider three polynomial P1, P2, P3. Which of the following option is true? P1 has only one real root, P2 has only one real root,
Ma'am,
P3 has
I
yeah.
I solved the quadratic equation, but I didn't able to solve cubic equation here. Then how will I will determine whether its root is real or not a real? That's my doubt.
Oh, so
Yes, ma'am. I am not able to solve the cubic polynomial, finding the roots. You was also told me hit and try method,
yeah,
but
you can try with it. But here
not
I don't think 1 minus 1 will work because 1 will get
uh,
1 minus 1. So, okay,
but
so
it's also time consuming. This matter.
hidden try method.
Yeah.
Yeah, correct. Time consuming. Just time consuming.
Basically, we have to hit and try only for three value: -1, 1, and 0.
See,
Mm.
so if they want to use a hit and try method, they will use one of these values. Okay, so let's try.
Other value they not work, ma'am. This method.
No, it will work, but if someone want you to use hit and try method, they obviously range between either 0, -1, 1, -2 or 2. Because we know that it's not possible to hit and try for so many numbers, right? Yeah, the calculation
Okay.
will become very tough. Uh-huh.
They will give range. Okay.
They will give you only such polynomial for which these are the roots, or some roots which
Okay.
are clearly visible. Okay, so ultimately what we want x cube plus x square plus 1 is equals to 0. We want to find out all those x for which this p2 of x is equals to 0. Quadratic is okay, we just want cubic. Okay, so if this is the case, what will happen? Uh, so there will be one real root that is we can surely say. And why is this so? Because if you take any complex root, so complex roots always come in a pair, always comes in pairs. So pairs means if you have one complex root alpha plus iota beta, another complex root will be alpha minus iota beta. So whenever a polynomial will have a complex root, they always come in a pair. But here we have a cubic polynomial. So we know that it can have at most three roots. At most three roots. So if they have three roots, so then obviously one should be real, and it is possible. So there are two cases. So two cases is that all three roots are real. Roots are real, right? And the second case is one is real and the two is complex, and they are complex in complex pair. So that means if one is alpha plus iota beta, another will be alpha minus iota beta. Okay. So now we have to check that is there are some type of roots. So has only one real root, has only one. Okay, so here you can use the little bit of calculus tool. So if I consider P2 of x to be equal to x cube plus x square plus 1, then P2 dash of x, I'm just computing the derivative. I'm trying my method, okay? So it is same as 3x square plus 2x, right? So 3x square plus 2x. And if we compute P2 dash of x is equals to 0, it will give us either x is equals to 0 or x is equals to -2. Okay, so derivative actually omits anything. So we have two cases. Either
Ma'am,
it is possible. Yeah,
if we use Newton Raphson method,
Newton adaptation method. What is that
that
method?
will I think work. You can do, ma'am. I will solve, then I will tell you.
Okay. So what is Newton adaptation method? I mean, let's see. But if we have a three polynomial, then for the roots we just have two cases. So either all the three roots are real, or one root will be real and two root will be complex. So what we can do, we can try something here. So suppose some number z is the root. Okay, so we can take suppose some z is equals to some r
Ma'am,
into cos theta.
can
Yes.
I say something?
Yeah, sure.
If we consider like that 3 3 cube plus 2x equal to minus 1 and then take a
Mm.
derivative of 3 cube and 2x, then solve it.
No, no, no. That won't give us anything. That's the
Okay,
reason that
ma'am.
won't give us anything. So here one rule. I mean, this question is not that tough if you know the rule that if we have a polynomial, then how many times it will changes the sign, that many real roots we have. So here it is not changing the sign because the sign of x cube is also plus, the sign of x square is also plus, and the sign of 1 is also plus. So here there is no change in sign. So that's why it will have one real root and the two complex root. But in our course, we haven't studied this particular rule, right? So we cannot do this question by that rule. So P1x only one real root, P2x has
Ma'am,
only. Yes.
I think if be able to find somehow the maxima and minima, how many time the maxima and minima of the point, the equation, then we can say that the number of root is real or not.
Yes,
Okay.
ma'am.
Yeah, that's
That's why
also
I'm saying.
okay. So that means P2 dash of x is 3x square plus 2x. So P2 dash of x is equals to 0 will give us x is equals to 0 and x is equals to minus 2 by 3. Right. So now what
Yes,
is
ma'am.
P2 double dash of x? So P2 double dash of x is 6x. So if x is equals to 0, P2 double dash of x is also equal to 0. So here our test will fail. Correct. But if you take P2 double dash of minus 2 by 3, then it will equal to 6 into minus 2 by 3. This is equal to minus 4, so less than 0. So here we have one maximum value
Yes, ma'am. It means it intersect x-axis at 2 points.
at 2 point. Because here if we have one maximum value, so suppose this is maximum value. Okay, so we can use maximum value and the limits also. So we know that P2 is a cubic polynomial. So as x goes to infinity, the
Ma'am,
P2 also goes to infinity.
if we use a wavy curve method, I think we get all roots.
But for wavy curve methods, we need factors. Without factors, we cannot use wavy curve method.
Oh, yeah.
Yeah, but here this idea is working, right? So we have one point. So this point that x is equals to minus 2 by 3. Okay. So here we have a point x is equals to minus 2 by 3, where the function is taking maximum value, whatever the maximum value is. And we know that this function is growing to infinity as x goes to infinity and growing to minus infinity as x goes to minus infinity. So this point will be our local maxima, right? So it will cut 1 times x-axis, that's correct. And it will go around this point and then go around. So that means it will have a 3 real roots. And what are those three real roots? That thing we don't. So that means px will have a 3 real root. That's correct. And if px this p2x having 3 real roots, so this will also imply that this p1x p2x into p3x has 2 real root. So ultimately, is this explanation works for you? Because we have one
Ma'am,
maximum point. Yeah.
but according to this, every equation crosses x-axis how many that many times? That's the real root. Is it true? Because x square minus 1
Yeah.
also
Yeah, x
intersect.
square minus 1 also in yeah, correct. X square minus 1 nahi. This function won't intersect x-axis. You are saying x square minus 1 intersected at x-axis.
Yes, ma'am.
No, it won't intersect. So you can just find
Yes, ma'am.
you
Yes,
can
ma'am.
just go
It
to the
go it,
response.
it go one unit above. Yes, ma'am.
1 unit above. So it won't intersect. But here we are getting one maximum point, and maximum is only happen if we have such kind of scenario, right? And this is a cubic polynomial with positive coefficient. So as x goes to infinity, it should go to infinity, and x goes to minus infinity, it should go to minus infinity. Correct. So that means we have to start from minus infinity time, and we have to cut one. Okay, so here one point is we also have to compute what is the P2 of minus 2 by 3. what is P2 of minus 2 by 3? So it is minus 2 by 3 the whole cube plus minus 2 by 3 the whole square plus 1. So the cube will become minus 8 by 3, square will become 4 by 3 and plus 1. So that is same as minus 8 plus 4 plus 3 by 3. So it is minus 1 by 3. So maximum value is negative. Okay, so we still haven't figured it out. So I'll repeat what are the things. Just let me copy this. It's a simple question if we use some other method, but
Yes, ma'am.
if we use just whatever knowledge we have so far, then I don't know.
Yes, ma'am. Because tried to solve it yesterday, I stuck and I tried to help with my friend. They helped me, but I didn't get that.
Correct. So see, okay, this one there is no. So here we have P1 is easy. Okay, P1 is easy. We have P2 and P3. So let's try to figure out something about this. So P2 of x is equals to uh, x cube plus x square plus 1. Okay, and P3 of x is equals to, okay, now I'm getting what we have to do. So P3 of x is actually equal to x cube plus x plus 1. X is equals to x cube
Ma'am,
plus.
I'm pasting in chat box what is the this method say.
Okay, so the Newton-Raphson method is iterative finding specific. Yeah, it is approximation method. So that's why I'm saying that there are methods which can answer this question very easily. So one is the sign method. So if you guys know the sign method, how many time the sign changes, that many roots we have. So that is the sign method also you can use. You can also use this Newton-Raphson, but that will give us the only approximation. We need exact root. So one thing I know here, so since we have to use complex number in some way, so let's take it any number z is equals to, so any complex number we can write it in this form, r cos theta plus iota sin theta. Okay, but still it will be little complicated.
I think in previous lecture, sir taught the fundamental theorem of algebra. It could help if we can use it.
Yeah, so fundamental theorem of algebra says this polynomial will have 3 roots. Correct?
I
This
think
Yes,
is the
ma'am.
it's
result.
depend on its degree.
Yeah, so it will have 3 root because it is a cubic polynomial, and 3 root can come in 2 ways. So the 2 ways are, so either 3 roots, all 3 roots are real, or there will be one real root, and 2 complex root. So if we find out one real root, then we can actually say what will be the another root. So let's try some hit and try. If we do, then P2 of 1. So P2 of 1 is becoming 1 cube plus 1 square plus 1, which is equal to 3. Right. So P2 of 1 is 1, and P2 of minus 1. Okay, now I'm getting what we have to do. So P2 of minus 1 is also equal to 1. So that will be minus 1 cube plus minus 1 square plus 1, which is minus 1 plus 1 plus 1, which is 1 only. Okay, but if you compute P2 of minus 2, then it will become minus 8 plus 4 plus 1, which is what? Minus 3 less than 0. Okay, so now here you guys are familiar with the intermediate value theorem. So that means
No.
so I'll let you know. So since this your polynomial P2 of x, it is a continuous function, correct?
Okay.
Continuous function, and it is having one value in the positive coordinate, which is nothing but our P2 of 1. So this is x is equals to 1, this is your P2 of 1, which is equal to 3, and one value we have in the negative coordinate, okay, which is P2 of minus 2. So at minus 2, if we compute, the value is P2 of minus 2, correct? So we have one value in the negative quadrant, we have one value in the positive quadrant, and the function is continuous. So that means it obviously cut at one axis here, correct? Am I right or not?
Okay, okay, ma'am.
Okay, so we know that there will be one real root. This is guarantee for us. Now the option says that only is the word which is bothering us, that P2x has only one real. So how we can tackle this onlyness? So for that, we can use a derivative, and the nature of derivative will tell us either our function is what we can say is strictly increasing or not. Okay. So now here, what is our p2 of x? So p2 of x is x cube plus x square plus 1. So if we take the derivative, p2 dash of x, this will be 3x square plus 2x. And this is same as x time 3x plus 2. So now here you can use wavy curve method, whatever you guys are saying. So wavy curve method says that what are the roots of this polynomial p2 dash? So the roots are x is equals to 0 and x is equals to minus 2 by 3. So this is 0, this is minus 2 by 3. And since the sign is positive, start with positive, negative, positive. So that means p2 of x, so that means p2
Ma'am,
of x will have
I think
positive sign.
sign depend on the power of a term. If power is odd, then it's positive. If power is even, then it's negative.
Yeah, it depends on power of the roots. So if the root has even power, then we won't consider the uh, points here. Minus 2 by
Yeah,
3 and 0 we are considering because they are a linear power. That's why it's correct.
yeah, yeah.
So here what you are getting, this will imply that P2 dash of x is actually strictly greater than 0 for all x is greater than equal to 1. So that means no matter whatever x will take from greater than equal to 1, the function will be increasing in this particular way, in this particular way. So that means once it goes up, it won't come back. So this will give us a guarantee that there will be only one real root. Okay. And if you compute the figure of this polynomial also, that will also say that there will be only one real. So that's why this P2 option is correct. So P2 will have only one real. Are you guys convinced with this explanation?
Too much complicated, ma'am. But
Yeah, I know. I actually don't see any complex solution here, that how we can use complex number to solve this, because if you use complex number it will become very tedious to solve. Like we have to do cube, then it will become cos 3 theta plus cos 2 theta sin theta, all those things. So let's try to do complex also using complex numbers too. So if we take z is equals to r sin theta, r cos theta plus iota sin theta cos theta. Okay, I think I okay, r cos theta plus iota sin theta. If we do that, then we know z cube is nothing but r cube. This will be cos 3 theta plus iota sin 3 theta. And also z square and so on. Then we have to substitute it. So I don't think there is any way we
ma'am,
can use complex number to
when
solve.
when I saw this lecture not show that types of method. After
Yeah,
that,
correct, correct.
how they expect ki I am able to solve this type of question.
Yeah, this question is based on complex number that I am really not sure. Because yeah, there are several ways to solve this question, but those are not taught in the complex number
I
lecture.
saw
So
multiple times that things. In these lectures, they will not show this method or teach this method, and they give me that type of question.
right,
It is
right. No,
mathematics, Sujal. They trying to check your capability of attempting how you can attempt a question
But
when you see it's a new type of question.
mhm.
if are you not able to solve this question? Yeah, you not. If suppose you don't you anyone teach addition, and you teach the addition someone, and you ask the multiplication, how did solve this person?
Yeah, it's okay, but see, these questions won't carry such much of credit, right? It will give a very small amount of credit in your. So it's some kind of challenge to you that if you can make, if you can think out of the
Yes,
box,
ma'am. They are only
yeah,
trying
Ma'am,
to
just the
make
but
us
capacity
ma'am,
that
capable
how
to
much
some
you
take
can think.
the challenge.
ma'am, but
Mm.
sometime I got like as a demotivated. Yeah, I'm not
Yeah,
able to
that's
solve this
but
question.
uh,
I'm not
you don't
perfect
have to
in
think. See,
integration
there are
and that
so many
topic.
questions. Yeah,
Yeah.
that's correct. But there are so many questions, and those questions won't link with your topic. So these are a very nice question, but there are other ways to solve this too. But for by complex number, I have to think how we can do. Okay. Is there any other doubt from this, Ritu? Any other
Yes,
doubt from
ma'am.
any other activity?
I got it. One a small diet in same slide, ma'am. Could you open it again?
Yeah.
In activity 10.2, ma'am.
Activity 10.2, which question?
Ma'am, question number one, ma'am. One a small diet in that.
Okay.
In option 3 and 4, ma'am,
Hmm.
how they said that option 3 is right, ma'am? Because
See,
R, yes, ma'am. Could you please solve it?
yeah, yeah. So here,
It is not related to option 1 and 2, ma'am. It's general, ma'am.
yeah,
Option 3 and
general.
4.
General. So see, just so here you just take z is equals to some x plus iota y.
Ma'am, but
So
yes,
if you
ma'am.
take
Z is a x plus iota y, but real part of Z that is only x,
right, so if you
and we
take
have
z
to
is equals to x
multiply
plus
I
iota
to
y.
them.
Right, right. So then what is iota z? So iota z is iota x and minus of y. Right. So this is same as minus of y plus iota x. So then what is the what they are
Not
asking?
iota Z, ma'am.
Ma'am,
Real iota z.
I think in
Real
question there is written that
iota z.
real part of
ma'am, if
I only
you,
multiplied x with I,
ma'am,
Okay.
because I think the real part of x, real part of Z is x, and we have to multiply I to them.
No, no, no,
I
no. This
didn't
is real part
multiply
of
I to
iota
them.
z.
ma'am, if we
That's
scale with z with iota, then
hmm.
real part of the complex number also multiply with iota.
Yeah. So it's not scaling. Iota is number for us, root, right? So we know iota multiplied by x will become iota x, and iota square will become there. So the multiplication is as usual in complex number, right? So you know two complex number are there. Then how to multiply it? So a plus cd. So then you will multiply a with c and plus iota a with d, and then plus iota b with c, and then minus of bd. Okay. So
Okay,
these
okay,
real number
okay,
you will
ma'am.
take separate and iota you will treat separate.
Okay, okay. I thought only iota with y and x will be remain constant.
Okay. Any
Ma'am,
other
in
doubt?
this question, my
Yeah.
doubt is that if we have to only take that real part of Z, what we should
Hmm.
take? Only x? Am I
Yeah,
right?
that will be x. That will be x, right? But if you multiply iota with z,
Yes, ma'am.
then the
Then
real part will change minus
okay, means if we multiplied I to Z, then we have to multiply I to the whole equation rather than
1. Correct,
only
correct.
x.
Right, because that's how complex number multiplication.
Okay, ma'am. Okay, ma'am. I think only I have to multiply x with I. That's why I'm doing wrong. Okay, ma'am. Now I
Uh,
got it.
any other doubt from any other activity? Anyone else? If you guys have any doubt. Okay, so if you guys don't have doubts from activity, you can ask from others' doubt. So Sujal, do you have any doubt? Any question you want
I
to discuss?
have don't doubt, but can you suggest any lecture or any video for integration? I'm not well.
See, okay, so for integration, see, integration is a little bit, I mean, it depends on your practice. How many
Yeah,
questions you will solve, that much practice you will get. But if you want to learn some of the basic tactics, I mean, there are some tips and tricks of integration. So I'll suggest you go through the either NCRT. NCRT will have a good amount of questions. So just solve the questions of NCRT, the integration chapters question of NCRT. But again,
If
don't
I,
go to theory of integration.
yeah, if
The
ma'am,
theory is okay.
I do JE level integration, then enough for this course, ma'am.
Yeah, it will be more than enough. You don't have to go to JE level. You just go and solve some question from NCRT for integration if you want to practice.
Okay, ma'am.
That will be much more enough.
Okay, okay.
Okay, JE level is two marks. There they have several cases, but in our course, just simple methods, simple substitution, integration by part, mainly some substitution works.
Yeah. Okay.
Any other doubt? If you guys have any, if you don't have any doubt, you can leave all. Mhm.
Thank you, ma'am.
Yeah, thank you for joining.
Because ma'am, in class 11th, I was think I prepare for a NEET.
Mhm.
Mm, Due to that, I am not solve like as
Okay, maths
integration
will,
and math.
right, right,
Yeah.
right.
Never. Then suddenly, I don't know what I do. Then suddenly in 12th, I take a engineering.
Okay,
Hmm.
that will be a problem.
Okay, ma'am. Bye.
But see, just go
Okay,
and
okay. Yes,
use
yes.
solve question from substitution. That's all.
Yes, ma'am. Yeah. Can you tell me something?
Yeah, just solve the question from method of substitution. Go to NCRT and
Okay.
solve the question from there. That will be more than enough for you.
Okay, okay, okay. Thank you, ma'am.
Yes, thank you for joining.
Yeah.